Hello guys, how are you today? So today I'll be explaining the Algebra 5.1 course practice because some people in grade 9 have requested me to do it for the finals. So for grade 10 we don't have any math periodics this week. Don't be scared. Don't think we have an extra periodic, please. I'm doing this for the finals of grade 9 and hopefully our finals. So let me just start. In the diagram below, MNPQ is a rectangle. Which of the following is true about the vectors in the diagram above? Let's take them one by one. The first thing says that 2MP is equal to minus PO. Remember, 2MP is equal to minus PO. So, MP, it is this. So 2 times MP, is it equal to minus PO? Minus PO, first of all, PO is like this. So minus PO is going to be the opposite, which is OP. This is definitely incorrect. Instead, what you should do is put it the opposite, is that 2 times minus PO is equal to MP. Very simply, this is what it means. Now, MO is equal to OP. Let us see. Because they are diagonals, okay? MO, it's equal to OP. This is very true. First of all, they are in the same direction and they have the same length. So definitely yes, MO is equal to OP. We move on to number 3. An M is parallel to minus NP. So let us find an M. An M, they said it is parallel to minus NP. So NP is this. Minus NP would be on the other side. Definitely they are not parallel. In fact, they are perpendicular. So definitely this option is wrong. The next option we have is NQ is equal to 2NO. So NQ, it is equal to 2 times NO. This is a fact. This is true. So NO times 2 is equal to NQ. This is definitely true. So yes, we are going to take it as a correct option. Then we have Mn is equal to minus QP. So Mn, it is equal to minus QP. So QP is like this. So minus QP would be the other side. Are they equal? No, they are not equal because they are going in opposite directions. So for sure, this is also incorrect. Now, finally, they said PM is parallel to minus MO. So PM, which is like this, it is parallel. They are saying it is parallel to minus MO. So MO looks like this. Minus MO would be going on the other side. Now, when you look at it, it's coincident. Coincident means they are two lines on top of each other. Okay, they are collinear. You cannot say collinear. Collinear is for a point. They are coincident, meaning both the lines are on top of each other. But if you move them, so if you moved minus MO, which is OM, if you moved it like this, you would see that, yes, it is parallel to the line PM. So from now on, if it is coincident, then definitely it is parallel, okay? However, coincident does not mean it is parallel. But if it is coincident, then yes, for sure it would be parallel. So the last one is also an option. We move on to question number 2. ABCD is a quadrilateral. Okay, AD is equal to A, BC is equal to B. DC is equal to B and BC is equal to C. E lies on AB such that AE is 1/3 of AB. Okay, keep this in mind. They said, which of the following are true? They want us to find the value of EA. Okay? We know, based on the given information, that AE, which goes like this, it is 1/3 of AB. So definitely if we are looking for EA, which goes like this, it's gonna be 1/3 of BA. So very simply, to find the value of EA, we need to find the value of BA. And then our whole life would be easier. So how do we take the points that will make BA? Very simply, you will take terminal point with terminal point. So the starting point with starting point and terminal point with terminal point. This over here is our terminal point. This over here is our starting point. So starting point with starting point. So it will move like this, C. And then you can never have two terminal points meeting unless it is the new ray or the new line. So for sure, this cannot be like this. This would be incorrect. So what's gonna happen is it's gonna be a starting point over here and a terminal point over here. And again, same idea. You cannot have the terminal point over here, so you would put a starting point. So now let us see what this looks like. So C, it's going in this direction. B, it's going in this direction. And A, it's going in this direction. So very simply, the value of BA, which we are finding right now, it is equal to C, okay, because we're going in the same direction as C. But B, we are going in the opposite direction of B, so it's gonna be minus B. And then finally, A, we're going also in the opposite direction, so it's gonna be minus A. And just like that, we found what? We found the value of BA. So if we have the value of BA, then for sure we will be able to find the value of EA. We know EA is a third of BA, so it's gonna be 1/3 times C minus B minus A. So EA is very simply equal to 1/3 times C minus B minus A. So this is the first option. We don't take the second one because we know it is wrong. Now the next thing they want us to find is EB. Let us find EB together. EB, it is this. First of all, we know that AE, it is a third of AB. This means what? This means that all of AB, it is equal to 3, and AE, it is equal to 1, and this leaves EB to be equal to 2. Okay, this is not their actual values, it's just like the relations between them. Okay, so if we are looking for EB, okay, then very simply, we know it's gonna be 2 out of the total, which is 3, 2 out of 3, of the total segment, which is AB. So EB, it is equal to 2 out of 3 of the total segment AB. Now, first of all, to find EB, we need to find AB. To find AB, we will start from here. This is our starting point, and this over here is our terminal point. Okay? So, oh my goodness, I lost it. So again, let me just write that EB, it is equal to 2/3 of AB, and now we are looking for what we are looking for, AB. So AB, okay, its starting point is over here and its terminal point is over there. So look what's gonna happen. It's gonna move like this. So first we start like this, so it's moving in the same direction as A. And then we move like this, because then again it's moving in the same direction of B. And then we will move like this, but it's moving in the opposite direction of C. So very simply, AB, it is equal to A plus A, because it's moving in the same direction. And then plus B, because it's moving in the same direction. And then finally minus C, because it's moving in the opposite direction. So now that we have the value of AB, we can find the value of EB. EB, very simply, it's equal to 2/3 out of AB. And we found AB, which is A plus B minus C. So very simply, EB, it is 2/3 times A plus B minus C. So it's going to be this one over here. Now, finally, they want us to look for CE. What is the value of CE? Like this. Now, there's many ways to do this, but I personally prefer to take the way with the less amount of sides. Okay, so you could take minus B minus A plus AE. This could work, so it will be minus B minus A plus AE. This is one way. Or another easier way would be very simply to take minus C plus BE. So whichever way works for you, it's fine. But for me personally, I would prefer to use minus C plus BE. So in the previous question, we found the value of EB. EB, if you remember, it was 2/3 of AB. And that means it was 2/3 times A plus B minus C. So what is the relation between EB and BE? What you need to know is that EB, it is equal to minus BE. So if we are looking for BE, then that means BE, it is equal to minus EB. So that means very simply that minus EB is equal to minus 2 over 3 times A plus B minus C. So it's gonna work like this now. Minus C plus, open brackets, minus 2 over 3 times A plus B minus C. If we solve it even more, we're gonna get, so this would be minus 3 over 3C plus minus 2 over 3A, okay, plus minus 2 over 3B, and then plus minus times minus is plus 2 over 3C. Okay, and then we add them, we solve them. By the way, why is minus C minus 3 over 3C? Very simply, 3 over 3 is 1, so minus C is the same as minus 3 over 3C. Very simply, that's how I did it. Okay, so minus 3 over 3C plus 2 over 3C, this will give us what? This will give us minus 1 over 3C. And then we will be left with what? Minus 2 over 3A minus 2 over 3B. Now, what we could do is we could take 1 over 3 as a common factor. So if you took 1 out of 3 as a common factor, you would get 1 over 3, okay, multiplied by minus C minus 2A minus 2B. So very simply, we found the value of CE, okay? So CE, it's equal to minus C plus BE. Very simply, CE, we found its value to be 1 over 3 times minus C minus 2A minus 2B. Okay, so if we go down and we look for a similar answer, here it's plus C, so we don't take it, we will take this answer because it's 1 over 3 minus 2A minus 2B minus C. That's pretty much it for question number 2. We move on to question number 3. So, question number 3. Referring to the figure below, O is the origin, okay? OA is equal to A, OB is equal to B, M is a point on AB such that AM to AB is 1 to 2. That means M is what? M is the midpoint, okay? So they need us to find the value of OM. Let us together find the value of OM. OM, there is very many ways to do it. An easy way would be to take it like this. OM, it is half of what? It is half of the total ray, which could possibly be, let us say, OX. It could be the total ray of, it could be half of the ray of OX. Okay, and very simply, based on previous examples, we know that OX would be equal to 1 over 2 times, without the 1 over 2, OX would be equal to OA plus OB. So it would be like this, OA is like this, plus OB, and together they will give us the value of OX. Okay, so very simply, we know that OM, it is equal to half of OX based on previous examples. So then you will know that OM, it is equal to what? It is equal to half times OA plus OB. This is one way to do it. Another way to do it would be to take OM like this. So OM, and then you will take one of the sides. For example, you would take OA and AM. So right now we know that OM, it's equal to OA plus AM. OA, based on the given, we know it's equal to A. AM, okay, we know it is half of what? It is half of AB. So let us find AB together. AB, very simply, it is minus A plus B. So AB, very simply, it is minus A plus B. So that means if we're dealing with AM, which is half of AB, it's going to be plus half of minus A plus b. So that means it's a minus 1 over 2a plus 1 over 2b. So very simply, it's 1 over 2 times a plus b. So very simply, it is 1 over 2a plus b. We move on to am. They want us to find the value of am. I think we already found the value of am. Am, we know it is half of ab. Okay? Half of ab. And very simply, AB, it is equal to what? It is equal to minus A plus B. So AB is equal to minus A plus B. So very simply, AM would be equal to half of minus A plus B. So AM, it is equal to half of minus A plus B, or half of B minus A. And AB, again, we found it many times. AB is like this. So that means it's minus A plus B. All right, so then very simply, AB is minus A plus B, or in other terms, it is B minus A. We move on to question number 4. Question number 4 is a very important question. Okay, it's very easy, by the way. They told us, refer to the figure below, AC is equal to A and BA is equal to B. So if we move on to the first question, which is A, they need the value of BC. Very simply, BC, as you can see, we will take starting point with starting point, so it is B, and then terminal point with terminal point, so it is also A. So very simply, BC, it is equal to B plus A, or A plus B, in whatever order you put it. So A plus B. We move on to part B. They said M is the midpoint of CA and X is such that BX to CX is 1 to 3. Fill in the blanks. They need us to find the value of XM. Value of XM. You can do this in very, very many ways. But a really easy way would be what? Would be to take XC and CM. So XM, it is equal to XC plus CM. Okay? So XC, we know that it is 3, and XB, it is 1. So in total, it's gonna be 4. That means XC, it is actually 3 over 4. 3 over 4 of what? It's 3 over 4 of BC. And we found BC in the first part to be A plus B. Plus CM, we know that M is the midpoint and is going in the opposite direction of A. So very simply, CM, it's gonna be minus half of A. So now you distribute and we're gonna add. So 3 over 4A plus 3 over 4B minus 1 over 2A. After adding, you guys have to add by yourself. It's very easy to add. You are gonna get that 3 over 4 minus 1 over 2, you do common denominator, of course, and you're gonna get 1 over 4A plus 3 over 4B. Very simply, that is it. So we found that it is 1 over 4A plus 3 over 4B. We move on to question number 5. In the diagram below, A, B, C, D, E, F is a regular hexagon. Remember from geometry, a regular hexagon can be divided into 6 equilateral triangles, okay? They told us that AB is equal to V and FE is equal to U, and that a hint, O is the midpoint of the diagonals. They need us to find, expressed in terms of U and V, the value of CD. Very simply, the value of CD. We need to find its value. What you can do is, there's no need to take the whole thing. So, for example, CD, it is from here. To start, it will go like this, then like this, then like this, then like this, then like this. This is really unnecessary. Instead, what you could do is CD. This is CD over here. You could translate the vector V. So you will move it to something that's parallel. You cannot take this. This is not parallel to V. Instead, you have to take something that is parallel to V. So it could be this over here. This is parallel to V. But we don't need it in this manner. Why? Because we said we always start starting point with starting point. So if V is going in this direction and we move it parallel and we put it in the opposite way, that means this over here is minus V. Same thing with U. You will just translate it, you will move it to something that's parallel. This is also parallel, okay? So we move it over here and it's gonna be U, but we do not change its sign at all. Why? Because terminal and terminal have met. So very simply, CD, it is equal to minus V plus U, or in other terms, U minus V. So if you go down and you click, it is U minus V. We move on to part B. Expressed in terms of U and V, BE is equal to, we need to find the value of BE. There are a lot of ways to find the value of BE. You could either take it from here, so like this, 1, 2, 3. This is one way to do it. But personally, how I would prefer to do it is like this. You can see that what? That BE, it is parallel to CD. And we said that all the segments are equal to each other. That means CD, it is equal to BO, and it's also equal to OE. So you are putting CD, but 2 times. That means BE, it is equal to 2 times CD. Okay? So, very simply, we found CD in the previous part. It is U minus V. So very simply, BE, it is equal to 2U minus 2V. Okay? So 2U minus 2V. We move on to part C. They need the value of EC. This is a very, very interesting question. The value of EC. So there are a lot of ways to take it, okay? But let me choose the easiest way for you. Very simply, you know that EC, it is ED plus DC. So AB and DE, they are parallel. That means V over here is the same as V over here. And we found in a previous case the value of CD, but here this is not CD, this is DC. And the relation between DC and CD is that DC is equal to minus CD. So you take the value of CD, okay? CD, its value is U minus V, so it becomes minus U minus V. And you also have V over here. So very simply, EC, okay, it is equal to V plus minus U minus V. This is U, okay? So V minus U plus V, so very simply it is 2V minus U. So EC, it is equal to 2V minus U. We finished from question number 5. We move on to question number 6. Now the questions will get a bit easier, okay? So in the diagram below, ABCD is a parallelogram. Match each vector in column X with an equal vector in column Y. They need us to find the value of BC. Very simply, BC, it is parallel to AD. So you will look for AD. BC, it is equal to AD. Now U, it is what? It is BA. And it is parallel to CD. So very simply, U, it is equal to CD. Now, DA, it is parallel to what? It is parallel to CB. So very simply, DA, it is CB. And finally, last but not least, is minus U. Minus U will go like this. So it's AB, and AB is parallel to DC. So minus U is DC. We move on to question number 7. Question number 7 is really easy. You look at it, it might seem hard, but it's very, very simple. So they said refer to the figure below. Okay? A and B have position vectors P and Q relative to the origin O. Now pay attention. M is a point on segment AB such that AM is 1, MB is 5. That means in total, AB, it is 6. Okay? They also told us that D is a point on the line such that AM is equal to BD. Keep this in mind, we will need it for the second part. Fill in each blank with a whole number. The position vector of M, OM, written in simplest form, is equal to. So we need the value of OM. Okay? Now, sorry, this is not really accurate, but it's just OM, okay? So let us take the easiest method. For different people, there's many methods that may seem easy to them. But to me, the easiest method would be to take OA and AM. So OM, it is equal to OA plus AM. Okay? OA, we know its value is P. However, AM, let us find the value of AM. We know AM, it is 1/6 of AB. So before we find the value of AM, we need to find the value of AB. So AB, it is equal to what? It is equal to, so this over here is AB. It is equal to minus P plus Q. So very simply, if AB is minus P plus Q, then AM, it's equal to 1/6 times minus P plus Q. Okay? We solve it even more, so P plus minus 1/6 P plus 1/6 Q. And then after solving, you're gonna get 5/6 P plus 1/6 Q. And just like that, we solve the first part. So it is 5/6 P plus 1/6 Q. Which of the following is equal to vector MD? Now, very simply, vector MD. Let us separate it into two parts. It's equal to MB, so MD, it is equal to MB plus BD. And as we read before, we know that BD, it is equal to AM. So now what we're gonna do is we're gonna substitute BD with AM. Now look how easy this will become. MD, it is now equal to MB plus AM. And we know that MB plus AM, so this over here is MB and this over here is AM, it is equal to AB. So very simply, MD, it is equal to AB. You see, just by solving as if they are numbers, we got that MD is equal to AB. And we found AB in the previous question, but I will help you guys find it again. So AB, it is minus P plus Q. So very simply, MD equals AB equals minus P plus Q. So minus P plus Q. We move on to question number 8. Click at the endpoints of the vector that's equal to LK plus LM. Very simply, here, okay, this is like, let me remember which question. It is like question 3, okay? But question 3, the difference with it is that it was half of the parallelogram. It was only a triangle. But here they gave us the full parallelogram. So they need the endpoints of the vector that's equal to LK plus LM. Very simply, it's going to be LN. You do not take LP because it's going to be half of LK plus LM. If you didn't understand why it is LN, very simply, what you could do is you could take, okay, LM and LK. Then you could translate them into something that's parallel. So what's parallel to LK? MN. Okay? And what's parallel to LM? It is KN. So like this, you have the starting point, which is L, where all the starting points meet. And then you have the end point, which is N, where all the terminal points meet. So very simply, it is L. Let me just do it correctly. L and N. Okay, so let's submit. Hopefully we do not have any mistakes. And thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.